I heard you guys saying that this was one of the hardest Emath O-level questions that appeared in paper 1 this year. But do you guys know that similar questions have appeared in all these years in the past actual O-level papers as well? If you're keen to learn how to solve this question, do continue to watch on. Let's take a look at this question. We have the graph drawn on the grid and we are supposed to draw a suitable straight line on the grid to solve the inequality. Now, to be able to solve this question, we need to make sure that the left-hand side of this inequality must be the equation of the graph that is already drawn on the grid. Now, if you take a look here, we have 4x cubed, but from the equation here is a negative x cubed. So how can we change it to negative x cubed? Is we can divide it by negative 4, because 4 divided by negative 4 will give you a negative x cubed. Now, let's divide by negative 4 across all the numbers here, and we will have plus 3x squared minus 3 over 4x minus 5 over 4. Now take note right here, when we divide by negative number, we need to flip the sign for inequality. So we'll have more than 0 right here. Alright, next thing, can you see that negative x cubed and negative x cubed is already the same? And can you see that 3x squared is also already the same? So what is left is to make sure we have the negative 1 here. And to be able to get the negative 1 here, this is what I'm going to do. I'm going to copy negative x cubed and positive 3x squared down. And now, I will minus 1 on the left-hand side of my equation, which also means that to balance out, I will actually minus 1 on my right-hand side of the equation as well. Next thing, do you realize that I haven't settled this part yet? So this part cannot suddenly disappear, right? So what I'm going to do is I'm going to shift this 2 over to the right-hand side of the inequality, and that will become positive 3 over 4x plus 5 over 4. What we can do is we rearrange it a little bit, and we have 3x squared minus x cubed minus 1. More than, now let's simplify this, minus 1 plus 5 over 4. Alright, we will get a 1/4. And then for this part, 3 over 4x, let's just write as 3 over 4x. When you get up to here, basically this is actually the graph that's drawn on the grid, which is represented by y, because y is equal to 3x squared minus x cubed minus 1. And this is actually the straight line you're supposed to draw, because you know that straight line is always represented by the equation y equals to mx plus c. So can you see that this is your m, this is your x, and this is your c? Alright, now to be able to draw this line, we need 3 coordinates. So to be able to get these 3 coordinates, let's draw out the table of values. Now to be able to get out the table of values, we need our x and our y. What do we sub in for x? If you take a look at this graph here, the smallest x value that we can use is a minus 1. Another suitable x value we can use is a 0. And not forgetting, we also want to take a look at the end of this graph here, which is x is a 3. To be able to continue to get the y values here, I'm going to use this, which is my equation of the line of y equals to 3 over 4x plus 1 over 4. Let's key into the calculator. When we sub inside x is negative 1 here, what do we get? So we will get a negative 0.5 in our calculator. Next, we are going to sub in x is 0. So let's replace the x here with a 0. And the calculator will give us a 0.25. Alright, so that will give us the y over here. Next, let's sub in our x is a 3. So if we sub in x is a 3, in our calculator here, we will get a 2.5. So in other words, to be able to get the line on the grid, we will plot in these coordinates. First, let's try to plot in when x is minus 1, y is negative 0.5. So let's take a look here. When x is negative 1, y is negative 0.5, which is in the middle here. Our very first point is actually this point here, whereby x is minus 1 and y is a negative 0.5. Next, we have x is 0 and y is 0.25. If we zoom inside here, to get 0.25, now see, from 1 to 0 is a value of 1. And the value of 1 is actually made up by 10 small boxes right here. So when we take 1 divided by 10, it means that every single box right here is a value of 0.1. Right? So we get 0.1, 0.2, 0.3, 0.4, 0.5, so on and so forth until we get a 1, right? So to get 0.25 is actually here. 0.1, 0.2 and 0.25 is in the middle right there. So which is actually a point right here. Last but not least, we also have the last coordinate. X is 3, y is 2.5. So let's take a look at the graph here, which we will get x is 3 and y is 2.5. Now let's join up these 3 points with a line. Now we want the curve to be more than the line. So for the curve, which is here, to be more than the line, it means, take a look, okay, I am going to highlight the line over here, and we want the parts of the curve that is higher than the line. So which parts are the one that's higher? It must be this part here and this part here that is higher than the line, because this part here and this part here, it is actually below that line. Can you see that? Yes. So to be able to get this part here, alright, let's zoom in to see what is the value of this intersection point right here. You'll realize that over here is a very nice number of a negative 0.5. And if we are looking at this part here, we want anything that is less than negative 0.5. Our final answer here, we will have x is less than negative 0.5, first answer. We also have to look at the other part of this curve, whereby it's higher than the line is here, right? So I'm going to look at the point of intersection here, which we will have 1, and we have the other point of intersection right here, which is a 2.5. Now, if we want the range from here to here is between 1 to a 2.5. So over here, our answer also include when x is actually more than 1 but less than a 2.5. And this is how we solve the hardest O-Level Emath Paper 1 question this year. I hope it helps.